Now I will show a simple agent-based model for exploring implementation processes. Here we see a diagram showing the implementation of an evidence-based intervention. Our emphasis here is not on the intervention itself, but on the implementation process. So we begin on the left side with patients which have a case mix, meaning that the patients have varying characteristics. They enter the intervention, and there are a set of processes shown in the middle of the slide. And it is here that the provider interacts with the patients. Then on the right side of the slide, we see the patients with their outcomes. Now I will begin introducing the components of the agent-based model. The most important components, as you can imagine, are the agents. In this case, the agents are the patients, shown on the left, and the provider, shown in the middle of the slide. Another important aspect of agent-based modeling are the processes. And here, we just put a circle around the processes in the middle of the slide. And we shall explore this in more detail. An important feature of agent-based modeling is feedback. And here we show feedback from two sources. The first feedback is from the processes and intermediate outcomes measures that can occur within the middle of the slide where the processes are shown. The other source of feedback is from the outcomes, from the left part of the slide. Now let's begin exploring the patient in more detail. For this lecture, we're going to use as simple of a model as possible for our patient. So here on the left, we see a plot. On the horizontal axis, we see the cumulative provider effort. And on the vertical axis is the cumulative effects of the provider on the patient. We'll be talking about these axes in more detail in the following. In the middle of the plot, there's a horizontal dashed line. So it is at this level where we have a division between an outcome of 0 and an outcome of 1. So an outcome of 1 means some kind of success. And it really depends on the kind of intervention that we are examining. So if this is a smoking cessation program, then outcome equal 1 would represent quitting smoking. So if this is an intervention on reducing blood pressure, then an outcome equal 1 may represent a target blood pressure. And another example is where there's an intervention on reducing BMI, the body mass index, and outcome equals 1 may represent achieving a target BMI level. So we have defined the horizontal and vertical axis, and we also have a threshold, this dashed horizontal line, where there is a successful outcome. So when the cumulative effects of the provider on the patient exceeds this horizontal line and goes above that line, then this represents a successful outcome. Now we have the patient model itself. So the simplest possible model for the patient is a straight line that starts at the origin. The meaning of the line is as follows. As we go in the horizontal direction, then the provider is providing more effort towards helping the patient. So as you go up this sloped line, then the patient is making progress towards achieving the outcome. So here we can see both the provider effort, which is the horizontal arrow, and the effect on the patient, which is the vertical arrow. So we start with the baseline, which is at the origin, and we go up that straight line that represents the patient model to that open circle. And we can see here that the patient is currently below the outcome threshold, meaning that the patient has not yet achieved the outcome, whether it is smoking cessation or achieving the target blood pressure or BMI. Earlier in the presentation, I mentioned that there was going to be a case mix of patients. So here we represent this case mix by using variable slopes. So in this plot, we show 3 patients. Patient 1 has the line with the steepest slope. And what this means is that the patient is most sensitive or most responsive to the provider effort. And we'll show this many times in the next few slides. Patient 2 has a lower slope. And finally, patient 3 has the most shallow slope. And we'll see how these 3 patients respond to the provider's effort. And here we see what happens when all 3 patients have the same effort from the provider. And the responses of the patients are quite different. Patient 1, who had the highest slope and was most responsive to provider effort, has the highest outcome. And in fact, patient 1, the circle shown in patient 1, is above the horizontal dashed line. This means that patient 1 has a successful outcome. Patient 2, on the other hand, has a lower slope and is less responsive to provider effort. So the circle there that represents the cumulative effects on the patient is lower and is below the threshold. So patient 2 has not been successful in achieving the outcome. And the same goes for patient 3, who has even a lower slope and is even less responsive to provider effort. On this slide, we show more than just 3 patients. Here we show 10. I could have shown more, but then it would have been difficult to see all of the patients on the slide. So we see here 10 patients, each with a different slope. And as you would expect, the ones with the highest slope, the ones who are most responsive to provider effort, are the ones who are successful. They have their outcomes shown in the open circles above the horizontal line, meaning that they have all succeeded in quitting smoking or achieving their blood pressure or BMI levels. Then there are those who have lower slopes, and those are below that threshold. If we count the number who have succeeded, then we see out of these 10 patients shown on this plot, 4 of them have been successful. And from this slide onward, we're going to focus on smoking cessation. So here we see that 4 out of 10 have quit smoking, and the remaining 6 out of 10 have not quit smoking. Now we're going to show this on the right side of the slide with another plot. The horizontal axis is the same. It's the cumulative provider effort. But the vertical axis is now a site level measure. In this case, we're seeing what is the quit rate, or in other words, what is the percentage of the patients in the site who have achieved successful outcome, in this case, quitting smoking. So for this example, 4 out of 10 have quit smoking. So that means at the site level, we have a 40% quit rate. And so we can plot a point in the plot on the right side with 40% in the vertical direction and the cumulative provider effort shown on the horizontal direction. So now we will see what happens if we change the cumulative provider effort. So in this slide, what happens is that there is less provider effort. This can happen for many reasons. The site may not have the resources to provide the time and the energy for the providers to treat the patients. Or it could be that there are too many patients for the providers to handle. But for whatever reason, we're showing here a lower level of cumulative provider effort for each patient. So on the left side, we see that with this lower cumulative provider effort, only 1 out of 10 patients have quit smoking. When we move to the right side, we plot this site level information with 10% in the vertical direction, so that's 10% quit rate. So when we look on the left side, we're going to plot this information with a 10% quit rate in the vertical direction and that lowered cumulative provider effort in the horizontal direction. So now we have 2 points on our graph showing the site level effects of varying cumulative provider effort. Here we add just 1 more point, and in this case, we have larger cumulative provider effort. So in this case, the site may have more resources available for the providers, and the providers can give more effort to the patients. So here we see that 7 out of 10 quit smoking. So when we plot this on the right side, we put a point at 70% quit rate and that higher cumulative provider effort. So here we take the case where we have many levels of cumulative provider effort, and we plot all of the points together to form a curve. And this is shown on the right side. The shape of this curve may be familiar to many of you listening to this lecture. It is the logistic curve, and we show an equation on the left side of the slide showing the logistic expression with a provider effort as shown. This is the only equation I'm going to show in this series because we're going to emphasize more on the basic processes and concepts in agent-based modeling and not so much on the mathematics. In this slide, I am showing the results of a curve generated by an agent-based model. In this case, I used MATLAB to perform the simulation, but this can also easily be done in R and other packages. So now I would like to move on to other aspects of the implementation processes. Here, I want to start looking at feedback. One kind of feedback is when the provider differentiates between different patients. So in this case, the provider may provide higher effort towards the patients who are most responsive and lower effort for those who are least responsive. Another important feedback process is more logical, and that is that when the patient achieves the outcome, in this case, when the patient has quit smoking, then the provider will no longer provide extra effort. So here, we show what happens when we put this feedback into our model. So we see 3 things here. First, let's look at the patients who quit. Those are typically the ones who are the most responsive to the provider effort. You can see this here, where those who have quit have circles that are right on top of the horizontal dashed line. What this means is that the provider will stop giving any more effort towards these patients, because once they have achieved their outcome, then the provider can move on and provide for the other patients. Next, we look at the 2 groups of remaining patients who have not yet quit. The ones with the highest slopes are the ones who are most responsive to provider effort. And then there are those who are least responsive, who have lower slopes. You can see here in the plot on the left side that the provider has provided twice as much effort towards the more responsive patients compared to the least responsive patients. So now we look at what happens at the quit rate at the site level on the right side of the slide. So these results are generated by the agent-based model that we programmed using MATLAB. And here what we see is a comparison between equal effort for all patients, shown in the solid line, and the case where we have twice as much provider effort on the most responsive patients, shown in the dashed line. And it can be seen that when the provider provides twice as much effort on the most responsive patients, that the curve moves towards the left. Another way to look at these 2 curves is to see what happens when we have a fixed amount of cumulative provider effort. And here what we're talking about is the provider effort at the site level. It will be the average effort for all patients. And if you compare the 2 results, you see that when the provider provides twice as much effort to the most responsive patients, then the quit rate becomes much higher. This could be interpreted in terms of efficiency, because by giving more effort to the most responsive patients, you will get a higher quit rate. In public health interventions, there's often a concern about the least responsive patients. So here, we repeat the analysis in the previous slides, except instead of putting the effort towards the most responsive patients, we put more effort towards the least responsive patients. So on the left side, you see that the patients who are the most responsive, which have curves that are the steepest, have less cumulative provider effort compared to those who are least responsive. and who have lower slopes. And as you would expect, by putting more resources and provider effort towards the least responsive patients, we're going to have a lower quit rate. And this is shown on the right, where we have the site level plot of quit rate versus the cumulative provider effort. And here we can see with the dotted curve, a much lower result for the quit rate. So here on the right side, we see what happens when we have the same cumulative provider effort averaged over the whole site and compare the different strategies. So the strategy where you put more effort towards the most responsive patients, of course, has the highest quit rate. And when you put more effort on the least responsive patients, the quit rate in this case is at 0%. But we shouldn't just look at the quit rate at the site level, even though that is an important measure of implementation success. Because if you look on the left side, you'll see that the least responsive patients are getting more provider effort. And not only that, the cumulative effects, even though they haven't quite achieved the outcome of quitting smoking, has at least gone up from their baseline. So this may be important if these patients move on to another intervention, because these patients would have started at a baseline not at 0, but at a level significantly higher than 0, and will be more prepared for the next intervention. So this concludes this session on the introduction to agent-based modeling. I hope you found this session helpful for learning about how this type of modeling can be applied towards mental health services research. So if you would like additional information, there are workshops that are posted at the ALACRITY Center at Johns Hopkins on the website shown here, and also on a clickable website on the lecture page.